Alright, hello everyone, welcome back to the Math Mindset, and in this video we'll be doing a highly requested part 2 of the SAT geometry series, and yeah, we're just going to jump in with question number 19. Okay, in the figure above, AE and CD are each perpendicular to CE. Alright, so we have these two line segments perpendicular to this red line segment right there, okay? And if x is equal to y, the length of AB is 4. Okay, let me write that down really quick. We know AB is 4 and BD is 8. Okay, so it's like that. And we want to find the length of CE. Okay. Well, we know this is a 90-degree angle. So 90 plus x plus y is 180 degrees. But we also know x equals y. When we solve the system I've just boxed, we get x is equal to y is equal to 45 degrees. So what that tells me is angle x is 45 degrees and angle y is 45 degrees, which means triangle ABE is a 45, 45, 90 degree triangle. So we can use our special triangle rules, because in any 45, 45, 90 degree triangle, so I'm going to say this is 45, that's 45. If the legs are both of length x, then the hypotenuse is x root 2. That's a special triangle rule. Well, here we know what the hypotenuse of ABE is. It's 4. So we can just write an equation. 4 is equal to x root 2. And if we divide by root 2, 4 divided by root 2 is equal to x. If we rationalize the denominator, we get 2 root 2 is equal to x. So AE is 2 root 2, and so is BE. Right? Well, let's keep in mind what the question is asking us. The question is asking what CE is. So CE, the length of CE is equal to the length of CB plus BE. We know what BE is. It's 2 root 2. Now we just have to find what CE is. Now how would we do that? Well, it'd be nice if right triangle CEBD, this one, was also a special triangle, wouldn't it? So let's try and find some angles within that triangle to see if it is. Well, I'm noticing that these two angles are vertical, which means they're congruent. So this is also 45 degrees. But then if this angle is 45 degrees, so is this. So we have another 45, 45, 90 degree triangle on our hands. And if we solve the same type of equation, 8 equals x root 2, we get the legs are 4 root 2. Both of them. So CE is just 4 root 2 plus 2 root 2 is 6 root 2. And let me circle that a bit better. There. And we move on. Let's see. Let me erase this. Oh, okay. Alright, number 20. Line QR is parallel to line PS, or line segment PS. In the figure above, what's the value of x plus y? Okay. Alright, so whenever we have two parallel lines, let me extend these parallel lines. Let me extend these parallel lines out really quick. So whenever we have two parallel lines like this, I'm going to extend them. Right, whenever we have two parallel lines and we have this transversal, our transversal here is QP, right, and we have two angles squeezed between them, their sum will always be 180, right? And that's true because of the same side interior angles postulate. Same side, meaning they're on the same side of this transversal, and interior means they're in between the parallel lines. So our answer to this question is just 180 degrees. There. Okay. Let's move on. Okay, in the figure above, if the legs of triangle ABC are parallel to the axes, which of the following could be the legs the lengths of the sides of triangle ABC. Alright, first of all, triangle ABC is a right triangle. So immediately we can eliminate any options that don't satisfy the Pythagorean theorem. And here it looks like we can eliminate B because it doesn't satisfy the Pythagorean theorem. And that's all we can eliminate for now. Now, besides the triangle, what other information do they give us? Well, this line right here, they give us 2 points that it passes through. It passes through the origin and it passes through this point. So its slope is just 10 minus 0 over 4 minus 0, which is 5 over 2. Right. And its y-intercept is clearly 0. So the equation of this line is just y equals 5/2 x. And then it's also important to note that this line segment AB is completely on the bigger line. So segment AB is on this line. All of the points on segment AB are on that line in red. So that means AB has the same slope as the line, the bigger line. But how would we calculate the slope of AB? Well, the slope of AB is just 5/2, right? So I'm going to denote S for slope. The slope of AB is 5/2. But what is the slope of AB in terms of the other legs of the triangle? Well, we know slope is just rise over run. Well, here the rise part is BC, and the run part is AC. So the slope of AB can be written as the ratio of the legs, specifically BC over AC. So we know, by extension, BC over AC is equal to 5/2. So the legs have to be in the ratio 5:2. And the only option that satisfies that is A. And we're done. Okay. The figure above is a right triangle. What's the value of 49 plus x squared? Well, here we have a right triangle. We have 2 legs, and we have a hypotenuse. What can we do? We can apply the Pythagorean theorem. 7 minus x squared plus 7 plus x squared is equal to 10 squared, which is 100. Now we can combine like terms. So when we expand everything and put them together, we get 2x squared plus 98 equals 100. And then that becomes 2x squared equals 2, and x squared equals 1. And we can just stop right here with x squared equals 1, because I want 49 plus x squared. That's just 49 plus 1. That's 50. And we move on. Alright, what's the radius of a circle that has a circumference of pi? Okay, so it'd be really nice if we had a formula that could describe the circumference of a circle in terms of its radius. That way we can solve for r really quickly. And there is a formula. So it's just 2 pi r is the circumference of the circle in terms of the radius. And then that's just equal to pi. You can divide pi from both sides. We get 2r equals 1. That means r equals 1/2. And we're done. Okay, number 24. Let's see. In the figure above, arc SBT is 1/4 of a circle with center R and radius 6. If the length plus the width of rectangle ABCR is 8, then the perimeter of the shaded region is... Okay. So I'm going to dot all the segments that are on the perimeter of the shaded region in red, okay? So this segment is on the perimeter. So is this. So is CT. And so is AC. So we know what segments we need to add up. So let me find the value of arc SBT, the biggest segment. Right? So the length of arc SBT equals a quarter of the circumference of the entire circle, right? Because this is a quarter circle. So it's just 2 pi r divided by 4. We know r is 6, so it's just 2 pi times 6 divided by 4. That's just 3 pi, right? So we know that SBT, that the length of arc SBT is just 3 pi. Now we need to find the length of the remaining items, right? So let me find the length of this diagonal AC, just on the perimeter. Okay. Now, from the properties of a rectangle, we know length AC is equal to length RB. These two diagonal line segments I've drawn right here, they're the same because they're both the diagonals of the rectangle. And all diagonals of a rectangle are congruent in length. So AC is equal to RB here in the picture. But RB is just a radius of the circle, and that's just 6. So we know AC is equal to 6, right? So we know, let me erase this really quick. So we know this part, AC is equal to 6, right? And now we just have to find the sum of this segment plus this segment, right? If we call this length of the rectangle x and this length y, well then we know that part is 6 minus x and this part is 6 minus y. And now if we add them together, what do we get? 6 minus x plus 6 minus y is equal to 12 minus x minus y, which is equal to 12 minus the sum of x plus y. Now what's x plus y? Well, it's just the sum of the length and width of the rectangle. But we know what that is. It's 8. So this is just equal to 4. So we have our entire perimeter. It's just 6 plus 3 pi plus 4, which is 10 plus 3 pi. That's B. And we're done. Okay, whoa. In the xy coordinate plane, what is the area of the square with opposite vertices at -2, -2, and 2, 2? Well, I'm going to draw a tiny coordinate plane here. Hold on, let me move down like this. Let me straighten this line right here. Just draw that. Yeah, okay. So let's say the point 2, 2 is right here. With the point -2, -2 will be right there. Not -7, -2, -2. And you says we have a square with opposite vertices, right? That are on this segment. So that means the line I just drew is a diagonal. So we could draw the square. Hold on, that's a bad drawing. We could draw the square right? Something like that. And we know that this is the square that the question is talking about, right? And we want to find the area of the square, right? So first of all, we need to find the length of this segment right here. We need to find the length, not that. We need to find the length of this black segment right here. And we can use the distance formula. It's just, let's see, 2 minus -2 squared plus 2 minus -2 squared this is just 4 root 2. So the length of that black diagonal is just 4 root 2. Alright? So this is just 4 root 2. Right? And how would we find the area of a square from this? Well, you should know that whenever you draw a diagonal from one vertex of a square to its opposite vertex, these angles become 45 degrees. So here we have a 45, 45, 90 degree triangle. Oops, what happened? Oh, well, everything looks like everything just got erased. Oops. Yeah, we can continue. Like we said, right? We have the square, we have the diagonal, we found out it's 4 root 2, and that's all we need. We know these angles are 45 degrees and 45 degrees, right? Because it's a diagonal of a square. This is a 90 degree angle. So using our special triangle rules, we know this side and this side are both 4, which means this is a square with side length 4 and area 16, and we're done. Okay, in rectangle ABCD, okay, let's draw this picture. Rectangle ABCD. Let me draw that a bit better. ABCD, like this. It's fine. ABCD. The point E is the midpoint of BC. Okay, so this is point E. Okay, if the area of quadrilateral ABED, we draw ED. So basically saying, if this quadrilateral area is 2/3, right? So that part is 2/3. What's the area of rectangle ABCD? Okay, so I'm gonna call the length of the rectangle X and the width Y. So this would be X, and this would be half Y. Now the area of the rectangle is XY. The area of this triangle is X times 1/2 Y times 1/2, which is 1/4 XY. Which means the other part is 3/4 of the rectangle. So 3/4 of the area of the rectangle is just 2/3. And when we solve this, we get XY. What happened this time? Oh my god. Okay. Let me get back. Sorry about that glitch, guys. So, like I said, we have A, B, C, D, right? Hold on. We have A, B, C, D. Point E is the midpoint of EC. We know that the area of quadrilateral ABDE is 2/3, and we want the area of the rectangle. So we let the length be X and the width be Y. We know DC is X and EC is Y/2 because it's the midpoint. So the area of triangle DEC in terms of X and Y is just X times Y/2 times 1/2, which is the area of a triangle. So that's 1/4 XY. And so we know 2/3 is equal to 3/4 of the area of the triangle. And solving for XY, which is the area of the rectangle, just gives XY is equal to 8/9. And that's it. That's our answer. Okay, the right circular cylinder above has diameter d and height h. Of which of the following expressions which represents the volume of the smallest rectangular box that completely contains the cylinder? Okay, so we know the smallest height we need is h, right? The smallest width we need is d. And the smallest depth we need is also d, because if the diameter of a circle is d this way, it'll also be d the other way. So it's h times d, which is d squared h, and that's b. Okay, if the volume of a cube is 8, what is the shortest distance from the center of the cube to the base of the cube? Okay, so immediately we can find the side length of the cube. We know the formula for the volume of a cube is s cubed, where s is its side length. S cubed is equal to 8, that means s is equal to 2. So if I draw the base right here, probably not like that. Right, the center will probably be somewhere up here, like that. And you want to find the shortest distance from the center to the base. Well, that'll always be a perpendicular segment, perpendicular to the base, right? And the center, right, if you draw the other face of the cube, the top face, the center is equidistant from both the top face and the bottom face, right? But this line segment is just equal to the height of the cube, and that's just 2. So our shortest distance is just 2 divided by 2 is 1. Right. So that's our answer. Okay, in the figure above, point A is the center of the circle, and segments BD and CE are the diameters. Okay. Which of the following statements is true? Okay, so we're asked a question about the relationships between two triangles. So our goal for this question should be to prove like, oh, are these triangles congruent or are they similar in some way? So let's try that. We can mark equal angles and equal sides. Okay, so straight off the bat, we know these two angles are equal because they're vertical angles, and that these 4 line segments are congruent to each other because they're all radii of the circle. Wait a minute. That means the two triangles are congruent by SAS. So by SAS, side angle, side congruency, we know triangle ABC is congruent to triangle ADE. Alright. So that means we know that these segments are length 6 and that this segment is length 4. So we know ED is 4, and that's one of the answer choices, and we're done. We know that's true. So that's our answer. Okay, number 30. Let's see. In the figure above, the two circles are tangent at point B, and AC is 6. If the circumference of the center of the circle with center A is twice the circumference of the circle with center C, what is the length of BC? Okay. So clearly AC is just the sum of the two radii of the circles. So I'm going to call the radius of circle A R1 and the radius of circle C R2. We know R1 plus R2 is equal to 6, right? And what do we also know? We know the circumference of circle A is twice the circumference of circle C. So 2 pi times R1 is equal to 2 times the circumference of circle C. So 2 times 2 pi times R2. Right, we can cancel the 2 pi, and we get R1 is equal to 2R2. We can substitute that back in. We get 2R2 plus R2 is equal to 6. And if we solve this equation, we get R2 is equal to 2. And we want the length of BC. Well, BC is just R2. So B is our answer. Alright, we'll do like a couple more problems before I'll end this video. So these will be the last 2 problems for this video, and then we'll finish the rest of this geometry practice sheet in the next installment. Okay, let's move on to question 31. The figure above shows part of a circle whose circumference is 45. Okay, if the arcs of length 2 and length b continue to alternate around the entire circle so that there are 18 arcs of each length, what is the degree measure of each of the lengths of arc b? Okay, so first of all, we know that the circumference of the entire circle is 45. So I'm going to write that down. So we know 45, and it's equal to the sum of these alternating segments, right? It's just 2b, 2b, 2b over and over again, right? And it says if arcs of length 2 and length b continue to alternate around the entire circle so that there are 18 arcs of each length, what's the degree measure of each of the arcs of length b? Okay, so it's just the arcs of length 2 and b going around the entire circle 18 times each. So this is just equal to 18 times 2 plus b. So we can solve for b here. All right. We know 45 is equal to 36 plus 18b. 9 is equal to 18b, so b is a half. Right? So we can set up a proportion here to find the degree measure of arc b. So we can say 1/2 over 45 is equal to x over 360. Right? It'll be the same proportion because there's 360 degrees in a circle, right? These two proportions will be the same. So we can just solve this proportion. We can cross multiply. We get 45x is equal to 180, and that means x is equal to 4. So it's 4 degrees for each arc of length b, and that's our answer. All right, on to the last question of this video. Number 32, in the figure above, the circle with center O is inscribed in square ABCD. What is the area of the shaded portion of this circle? Okay, let's see. All right. We know what the radius of the circle is. Right? It's just 1. And this is also 1. Right? And the diameter of the circle bisects side length BC. So BC, I want to call this intersection point X. BX is 1, and CX is also 1. And this is a right angle as well. So that means side length OC is root 2, and so is this side length OD. And we know CD is 2. But wait, the side lengths of this triangle, right, triangle COD, they satisfy the Pythagorean theorem. Because square root of 2 squared plus square root of 2 squared is 2 plus 2 is 4, which is 2 squared. So that means this angle right here, angle O, is a right angle. So that means this region is just a quarter circle. So it's just the area of the circle divided by 4. So the area of the shaded region is pi r squared divided by 4, where r is the radius. We know what the radius is. It's just 1. So it's just pi over 4. It's A. And then we're done. Alright guys, that'll be it for today's video on SAT geometry topics. I will post the last installment of this worksheet series very, very soon. Until then, stay tuned, and if you enjoyed this video and learned something useful from it, please don't forget to subscribe, leave a like, and share it with those that might find it useful in their SAT prep as well.